Hello class, good afternoon. Today we're going to be learning about dots.
Dots is in kindergarten.
No, you imbecile, not dots, dots. Okay, so would anyone like to tell me what DOFS stands for?
I think I can get it.
Alright, come up here. Let's see what you got. Okay, so first of all, you didn't even spell two of those words right. But second off, no, that's not what it stands for, bro. Get back to your seat. Alright then. Does anyone else want to actually give it a shot?
I would like to write it correctly.
Alright, come up here, Axel. Great job, bro. I like the cut of his jib, unlike someone. Alright, does anyone know what direction is?
Division.
Oh my god, it pains me how. So basically, direction is just what direction the scatter plot's going in. So say you have a set of data, and it looks like, this. The direction would be a positive direction, because the general trend for these dots is positive. But say you had it reversed. You had it so that, the older you are, the less likely you are to live, and then it would be negative. Because,
Teacher?
yeah.
Would it be the same thing if you're trying to find directions to like a McDonald's?
No, it would not be.
Oh, okay.
Alright, so anyone want to talk about outliers? Well, anyone?
I think I know about the outliers.
Alright, what do you think it is?
So an outlier would be like us over here, right? Like we're the cool kids and stuff. And then you'd have the loner, like that guy over there by himself.
Hi guys!
Don't look at him, don't look at him, don't look at him.
So actually, you're exactly right. This outlier is, a point that doesn't fit in with the rest of them, and therefore, it skews the rest of the scatter plot. So maybe the line of best fit was here before, but now it might be down here, just because of one outlier. So not only is it just something that doesn't fit in with the rest, it also drags down, or maybe skews it in a way that it might not be accurate to the actual data.
So an outlier could pull the line of best fit downwards or upwards depending on where it's located?
Definitely. Alright, so now we're on to second to last topic, form. Hey David, get off your phone. Swear to God, these kids. But yeah, so does anyone want to tell me what form is? Yes, Axel, you've been a bit quiet lately.
Isn't it where it's a straight line, linear?
So like whether or not it's a straight line, yeah.
Yeah.
So there's really two types, there's linear and like non-linear. So something like this, that's a linear one. And something like a data set where the data goes down kind of like this.
That's exponential.
That's an exponential one. And generally, we do not use these. If the data turns out like this, we consider it unusable, and we don't. So we only want linear form when we do this.
So let's say there's a graph that's like a arc type of thing. We wouldn't be able to use it because
No.
it's not straight.
Not for statistical purposes. No. So now, onto the last part. Strength. So can anyone, wait, where did David go?
He dropped out.
Oh my god. Alright. So, but can either of you tell me what strength is?
How strong the graph is?
Sure.
Can I show you an example?
Yeah, you can, Axel.
So this is a weak correlation,
Mm-hmm.
and this is a strong correlation. The more dots that are close to the line, that means they're strong.
Yeah, so the more accurate the line of best fit is, or the least amount of distance between points and lines, that is the line, yeah, that is correlation. So correlation can be from -1 all the way to 1. So unlike most math where -1 would be weak, or because it's negative, -1 is actually the strong value in the negative direction, so when the slope is negative, and 1 is the strongest it can be when the slope is in a positive direction. And 0 is actually the weakest it can be when there's no correlation at all. So the way we find correlation is this equation, where we take the y and x values of all of them, and then find the z-score, multiply them together, add them all up, add up all the values, and then multiply by 1 over the number of values that you had, number of dots on the scatter plot, minus 1. And that's how we get correlation. Or you can just do it with a calculator, that's way easier.
Okay.
And that's DOFS.